So we're doing more practicing of factoring complex trinomials today, but we're adding a little bit more detail to it as well. We are going to start looking at the question and identifying what kind of a question it is. So this becomes an important part of this whole process later this week. We're doing something a little bit different tomorrow, and then we're going to start putting all of it together. Okay? And this is a little step in that direction. But mostly our practice today will be more factoring complex trinomials. So these are you could kind of consider these steps like they're bullet points, but it's kind of like first do this, then do this, then do this, then do this. Okay, so they're kind of in order. So the first thing that it says is identify the type. Okay, so if I have something like this, and it would be ax squared plus bx plus c. What does it mean if it's a simple trinomial? And what does it mean if it's a complex trinomial? The ax squared plus bx plus c is just a general case. It could be anything. It could be either of those two examples below. So a, b, and c are numbers. How do I tell if what I'm looking at is a simple trinomial or a complex trinomial? First of all, they're both trinomials. We did simple trinomials last Thursday. Simple trinomial, what does trinomial mean? 3 terms. And then complex trinomial, so still 3 terms. So they both have 3 terms, but what's the difference between them?
I think the difference between them is like simple does not have an a, there's no value for a.
Right.
Complex does.
That's exactly right. If you look at that learning goal we just took up, all of those are just x squared. Not 3x squared, not 4x squared, not 2x squared, just x squared. Those are all simple trinomials because of that. Okay? And so what we say is a equals 1. So there is a coefficient, but we don't write it, right? X squared means 1x squared. So the a value is 1. That's what makes it simple. So how would we say what a complex is if a does not equal 1? It's still going to be an integer. It's almost always positive. It doesn't have to be, but while we're just learning it is. So it might be 2, it might be 3, it might be 4, 5, 6. Obviously anything, any integer, right? But not 1. That's what makes it complex. So that's one of the first 2 things we do. The first 2 things you can do in either order. You're probably going to kind of do them both at the same time. Okay? The first thing is you're thinking about, is this simple or is this complex? The next one says, always, big capital letters, always, 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 always. This is just always true. Not just today, tomorrow, the next day, forever, every time you're factoring. Always look for a common factor first. Okay? So you are identifying the type, but you're also looking for a common factor. If you successfully find the common factor, if there is one, you won't find one at the end. But if you miss it, it might be there. So after you finish factoring, before you're ready to move on to the next question, if this is a test or even your homework or whatever, look at your answer and look for a common factor. This is a hard habit to get into. This is something that not many people do. Because you usually probably do find the common factor first, so you don't bother looking at the end. But it's always a good idea to check at the end to see if what you have done is finished. And then the last step is always check your work. A lot of stuff that we do, if you think about it, especially in the first unit, and definitely in this unit and the next unit, you can check your work. Like there's a perfect check so that you know 100% that your answer is correct. So if you're handing in a test or something, you should know exactly which questions you got right and which ones you got wrong, but I guess couldn't find your mistake or something like that, right? You should know, because when I factor, I can check it by re-expanding. I don't do that in the question. Do it on scrap paper, but you can always check. So it's a really good habit to get into. Whenever you have like a perfect check, remember when we did solving equations, and I said even like we did solving linear systems, and I said If it doesn't say solve and check, you don't have to check, but it's a good idea. You might as well just on your calculator informally quickly check, right? Same thing here. If you can check, why not? Okay, so these are good habits to be in. Okay, so let's take a look at the first one. Factor fully are our instructions. Even if it doesn't say factor fully, that's always what you're supposed to do, factor fully. Do you see a trinomial here? Yes. Is it simple trinomial or complex trinomial? Why do you say that? Right, it's 2x squared. So it's not a simple trinomial. Except what are we always supposed to do first? Mahmoud? No. Look for a common factor. Always look for a common factor first. Is there a common factor in this? Don't you agree this looks like a complex trinomial? Is there a common factor in there, Kristen? What do you think? You don't think so? Riley, what do you think?
2.
Why?
Every term is divisible by 2.
Yeah, they're all even. So I can divide 2 out of each of them, can't I? That's what we mean by look for a common factor. So let's do that. You don't just look for the common factor. You common factor it. Okay? So 2, and divide that out, and I'm left with x squared plus 11x plus 28. Kareem, now what does it look like? What's left in the brackets? Do you think it's still complex? Why? Because of the 2 way out front?
No, it's not.
It's not. You're just looking at what's in the brackets. It's simple, exactly right. So it's not that we were wrong in the first step. That was the exactly right way to do it. Oh, there's a 2 here. That's not a simple trinomial. But let me see if there's a common factor. Oh, there is. I'll divide it. And then look again and decide, wait a minute, this is a simple trinomial. So common factor it that way. The way we factor simple trinomial and the way we factor complex are different. Complex, we have to dance. Simple, it's just 2 numbers that multiply to 28 and add to 7. That's easier, faster, okay? So we want simple trinomials when we can. So try to factor that. Don't forget the 2, it doesn't disappear. 2 numbers that multiply to 28 and add to 11. Pat, what'd you get? 7 and 4, and everything's positive, so everything's positive. Oh, that's not 4. 7 and 7, no. 7 and 4, beautiful. How many people got 7 and 4? So there we go, that's fully factored. If I expanded all of that, expand the brackets first, and then multiply everything by 2, I would get back that original question. Okay, that would be my check. Don't do it here. Don't go, okay, which equals 2 times. Don't do it right below. Okay, because that's the answer. That's where you need to stop. But off to the side somewhere, or even if you wrote, like, I don't think you should do this because I think you just try to do it more in your head, but check and then did something like that. I mean, that would pass if you made it clear, but you won't have enough space necessarily. Okay, so that one was like a simple trinomial in disguise because it had a common factor. That's why you always common factor first. Don't write this down, but watch. If I had tried to factor this the complex way by dancing, I need to find 2 numbers that multiply to 56, and then when I cross multiply them, they add to 22. Like, those are going to be big numbers. So what multiplies to 56? I mean, 2 and 28, that's not going to work. 4 and something. Like it's going to be tricky, right? It works out to, 4. 4 here and 14 here. Is that right? So 2 times 4 is 8. 8 plus 14 is 22. And then look, There's a common factor in there. You'd have to factor it out afterwards. Yes?
I wasn't here on Friday and I watched the video lesson, so I didn't get to see the dance move.
You'll see it in a few minutes. Okay, so that's what it would look like if you don't common factor first. Way harder, way longer, and you'll probably forget to common factor out the 2 in the end. Because then I would go 2x plus 7, x plus 4. Same answer. It's doable, but it's a lot harder. Okay, let's try this one. Trinomial, check. Simple or complex? Ziggy, what do you think? Why? Very good. Complex because it's 2x squared, not just x squared. But wait, is there a common factor? There is not. Very good. So this is a complex trinomial. So go ahead and try it. This is where you need to have a strategy. You can't just stare at the page. So one of the ways that you can do it is I started by writing out part of it. But this is a tricky way. This is like an advanced way of doing it. Noticing that 2 is prime and trying to do it in place. So what's the best way to do it? Probably write out the factors like this. 1 and 28, 2 and 14, 3 doesn't work, 4 and 7. Right, so the factors would look like this. Here's the dance move. You ready, Riley? Yeah. Start with your left hand up, your right hand down. Multiply, and then switch, and add. Didn't work. Multiply, switch, and add. Didn't work. Multiply, switch, and add. Oh, that one works, so this is my dance move. Good, right? So 1 times 7 is 7. 2 times 4 is 8. 7 plus 8 is 15. So there it is. Circling them like that, I think, is a good idea, because then when you start trying to transfer your answer, you don't lose track of what it is. 1 times 7 is 7. 2 times 4 is 8. You don't have to do that, though. Like, you don't have to write down that stuff, right? You can if you want, but... Okay, so this is x and 4. And 2x and 7, so you read your answer across the page like that. And everything's positive, everything's positive. Smile twice to check. 8 plus 7 is 15. Okay, good. Let's try this one. Don't forget you have to take the negatives into account here. Don't stare at the page. Start writing. Start with the factors of 6. I'm going to flip those. Factors of 20. What does that negative sign tell me? What does that negative sign tell me?
So let's say, first of all, the first number is a complex, right? And then what's your next, what's it called, idea? find out that there's a number that goes through them all.
Like a common factor?
Yeah.
Then you common factor it out just like we did in question A. So in that case, I pull the 2 out. I divide it out of everything to see what's left. And then what I'm left with here, I factor that. And I have to, like in some cases, I'm going to do it one way. In other cases, I'm going to do it. Every question's a little bit different. How many people have the answer to this one? A few. Good. Okay. I'm going to give you another minute. Watching other people factor will not teach you to factor. You have to do it yourself. And like I said, don't just stare at the page. Try something. Start dancing. Start eliminating options. So start with the 1 and the 6 and try it with all 3 on the right. How many people have it now? Okay, good. A few more. Okay, good. Good. So if you didn't get it yet, or you're not sure, this is what I would do. I would start with the 1 and the 6. Try it with every one. And this is the thing. Once you get practice at this, you don't necessarily fully do every single one. Like sometimes you kind of get part way and you're like, there's no way that's going to work. But be careful. You have to be good at that because sometimes you make a mistake and that's the answer. They multiply to a negative. They're multiplying to negative 20. So they have different signs. So I'm going to find a difference of 7. So I'm looking for 2 numbers. When I multiply across the line, above and below, and switch and dance, they have to have a difference of 7. 1 and 20 and 1 and 6, no. That's 20 minus 6, 14, no. 1 and 10 and 2 and 6, 12 and 10, no. 5 and 24, not even close. So it's not that one. I checked it with all 3. I checked it carefully. 2 and 20, no way. There's no chance, right? Like 40 is not gonna, and then 3, like you don't have to actually do the subtraction. I know that's not even close. 20 and 6, nope. 10 and 12 again, nope. So it's not that one. 3 times 20 is 60. No, again, no way. 3 times 10 is 30 and 4, no. 15 and 8, there it is. 3 times 5 is 15. 2 times 4 is 8. 15 minus 8, 7. So there we go. 15 and 8. And now I put them in place. So 3x and 4, 2x and 5. And I guess and check, or I just kind of figure it out which one's going to be negative. So I want the sum in the middle to be negative. That one gives me 15. That one gives me 8. I want the 15 to be negative. And there's my smile twice to check. That gave me negative 7. 3x times 2x is 6x squared. 4 times negative 5 is negative 20. It's all good. Yes?
I have a question about that one.
Sure.
I got 2x minus 5 and 3x plus 4. Does that make a difference?
No, absolutely not. 3 times 2 is 6. 2 times 3 is 6. Same thing, right? Yeah, so it doesn't matter what order you write it in. Okay, last one. Trinomial, check. These are all trinomials that we're doing today, so we don't really have to worry about that. But it's something to notice because that does become important. It's trinomial. Does it look like complex or simple? And is there a common factor in there? Liam, what do you think? What's the common factor? Do you agree that there's a 3 in each of those? Can be divided into each? Can be divided into 6, divided into 9, divided into 60? Very good.
Yes.
Yeah, absolutely. So let's do that. 6 divided by 3 is 2x squared. 9x divided by 3 is minus 3x. Negative 6 divided by 3 is minus 20. But look, still complex. There's no rule like when you common factor that you end up with a simple trinomial. Sometimes you do, sometimes you don't. I'm pretty sure the practice today, they're all complex trinomials one way or another, because that's really what you're practicing. But some of them have a common factor anyway. Okay, so try this one. Okay, check your answer.